Hey everybody! This video is going to talk about finding the domain of a fractional function involving radicals. Now this video goes over some topics that were discussed in domain of a rational function and domain of a square root function. So if you aren't solid on those concepts yet, go check out those past videos. For these, we have to consider both that it's a fraction and that it has a square root in it, or a radical in it. So we know that with the radical, that the inside has to be greater than or equal to 0, because we're not going to deal with imaginary numbers, right? We don't want any negative numbers in there. But we also know that because of the fraction, the denominator cannot equal 0. So let's take a look at each of these. For the denominator, if I add 21 to both sides, x cannot equal 21. Okay, so in this function, if I put in 21, I'm not going to get anything out, so that 21 is not in the domain. Let's solve for x on this side. So I add 2 to both sides and get 4x is greater than or equal to 2, and then divide by 4, and we'll get x is greater than or equal to 2/4, which is 1/2. So what would this look like in interval notation? Well, in interval notation, x greater than or equal to 1/2 would be a closed bracket, because we say we can have 1/2. 1/2 is okay. 1/2 is going to give us 0 actually. And then I'm going to continue, and x can be anything bigger than that, so I'm going to go to infinity. But pause, because x cannot equal 21 in this function. So when I combine the two, okay, I can go from 1/2 up to 21, not including 21, so I have a soft parenthesis there, and union that with 21 to infinity. So that's kind of how I break up this interval to include this x cannot equal 21 as well. So this is my answer for the entire function. This is the domain of that function. So that is finding the domain of a fractional function involving radicals.